Okay, so I got a robot. I got an R3 and follows a path in the Z direction, follows a path in the theta direction. So R theta Z tells me I'm dealing with cylindrical or polar coordinates. And basically what it's saying is, hey, give me the acceleration when t equals 3 seconds. So we're going to go through, we're going to find R dot, R double dot, theta, theta dot, theta double dot, and move through that way. So R equals 3, and it apparently stays at that distance. It's a fixed length, so that means R dot goes to 0, R double dot goes to 0. Okay, now we'll go ahead and talk about theta. Theta equals 0.5 t. Theta dot then goes to 0.5. Theta double dot then goes to 0 as I take those time derivatives of 0.5 t. So that is pretty straightforward. What I can do is for theta, I can go ahead and plug in time equals 3, so that becomes 1.5 on for theta, okay, at 3 seconds. Now we'll go ahead and do z, and we'll find that z is 3 sine of 4 theta, okay? Going to z dot. Now, here's the thing. I'm differentiating with respect to time. This equation does not have time in it. 3 is constant, so that's going to be left alone. But what I need is I need the time derivative of what's inside the sign, which is going to be 4 times theta dot, right? It's not just 4. I'm not differentiating with respect to theta. I'm differentiating with respect to time. So it's going to be 3 times the derivative of what's on the inside there, which will be 4 theta dot, and then the derivative of sine is just cosine, so I go cosine of 4 theta like that. Now, I plug in what I know. I know theta is 1.5, right? I know theta dot is 0.5, okay? So I can go through and I can find that this becomes 5.76. I probably should have done that up here as well, taken that 1.5, thrown it in here. Now, just when you type these into your calculator, make sure you're in radians. Again, when we start doing calculus on angles, we kind of have to use radians, unfortunately. So just make sure you're in radians. And then this becomes negative 0.838. So again, they gave me z. I know what theta is when time is 3 seconds. Plug that in and get z. I take a time derivative, plug everything in to find z dot. Now I need to do z double dot. So I'm going to take that 12 theta dot times the cosine of 4. So I'm going to pull the 12 out. That's constant. That's going to show up everywhere. But then what I've got is theta dot cosine 4 theta. Now I've got thetas in 2 places, so I kind of have to take the derivative of the first times the second plus the first times the derivative of the second. That's the product rule or whatever they call that, right? So that'll become theta double dot times the cosine of 4 theta, right? Plus theta dot times 4 theta dot, and then going from cosine, take a derivative of cosine, I get to negative sine, so it's going to be negative sine 4 theta. And again, remember, you're differentiating with respect to time. You're using that product rule, so you get this big long equation that looks like this. However, I know theta, theta dot, theta double dot, right? So this guy, this is going to 0, right? So it's really just 12 times 4 theta dot squared times the negative sine of 4 theta. Again, knowing theta, theta dot. This would actually be a, won't this be a negative? This will be a negative value because I've got that negative there. That'll be negative 3.35. And that's z double dot. Okay, so from this, I want to find the velocity and the acceleration now that I know this. Okay, so I know all my z velocity and acceleration, that's given right there. Okay, but what I do need to do is I need to go through and need to find VR, which again is r dot, which we know to be 0. I go v theta, which is going to be r theta dot, which will be 3 times 0.5, which is going to be 1.5. Okay. Again, I have the z dot, so now I can find the total v equal to the square root of 1.5 squared plus the 5.76 squared. And from that, I can find the velocity equal to 5.95, and that's going to be feet per second. So again, find the velocity in each direction, r, theta, and z, and then take the square root of the sum of the squares to get that. Now we'll go through and do the same thing with the acceleration. So the acceleration in the r direction is r double dot minus r theta dot squared. Okay, that guy goes to 0. I'm just left with negative 3 times 0.5 squared. That gives me negative 0.75. That's the acceleration in the r direction. The acceleration in the theta direction is r theta double dot plus 2r dot theta dot. Okay, theta double dot 0, r dot 0, so this becomes 0. So my total acceleration is just going to be the square root of 0.75 squared plus 3.35 squared. That's my z direction, okay? Because this is really just az. This is, that's vz, excuse me. This is az, okay? So we just take each of those, square root of the sum of the squares, and I get the acceleration equal to 3.44 feet per second squared, as shown there. So again, just find all those dots, r dot, theta double dot, so on and so forth. Use those to find your acceleration in each direction, and then square root of the sum of the squares to find the magnitude.